This conference will now be recorded.
Okay, so today we are going to uh, spend time with one of the most important tool which we have in MLOps, and that is MLFlow, right? So yeah, this tool is basically from the Databricks, and we are going to spend some time with this tool and then see how it goes. So what is Databricks? So basically, Databricks is a kind of a company who who has been pioneer in developing solutions for data engineering, data science, and machine learning. So basically, uh, the founders is from the same group who who have developed the Apache Spark. This company has also created Delta Lake, MLFlow, Coalesce, and many other open source projects. So yeah, Databricks, a cloud native platform for big data processing, machine learnings, and analytics built using the data lakehouse architecture. So these platforms, you have many different features. Though we have many different features, but we will be focusing more on machine learning part. So Databricks have one feature called Database SQL. This platform which can be used for analysis of running the SQL queries on data. You can create a dashboard visualizations and share a dashboard. So this is one of the most popular tool which they had initially. Second one which is we have is Databricks data science and engineering platform feature, which is interactive, where you have interactive workspace for collaboration between data engineers, data science, and ML engineers to generate insight using Spark, Apache Spark. And the last one, which we have, is Databricks machine learnings, where you integrate end-to-end machine learning environment with managed services for the ML workflow. So I have logged into one of the Databricks account, and here you can see that something similar. So when you go to the home page, you will see this is the related to SQL. Uh, so if you want any SQL operations, dashboarding, visualizations, analysis, and all kind of things, this is good for you. Good for them. Now, data engineering, here you have this, and this is for data engineering and data science. Here you have workspace, where you can do lots of data engineering and data science work. And for us, this is the important features. Now, if you see that, experiment, features, model, and serving, these are the one for us. This is for AI and ML. So this part which is going to be useful for us. uh, Databricks ML runtime, the one which I was showing you, which can help you to automate the creation of clusters, optimize for machine learnings, and it supports plenty of ML libraries. Some of the ML libraries which we have covered: scikit-learns, TensorFlow, and PyTorch. So apart from that, so many library it supports. Also, it includes the support for distributed training libraries such as Horud, include tools to automate the model development process, and also perform hyperparameter tuning to find the best model. So some of the features which we have is like AutoML, which automatically creates, tunes, and evaluate models. Okay, so AutoML is like automated machine learnings. So this feature at Databricks, which is very helpful for all the ML machine model developers basically. You have a managed ML flow, where you manage the end-to-end model life cycle, including tracking, experiment runs, deploying, registering, and sharing of models. And the another feature is HyperOpt, uses the Spark tile classes to simplify hyperparameter tuning by automating and distributing model using tuning runs. So these are the typical end-to-end machine learning environments which we have. First one is data preparations. Second one is which includes data source and delta tables. Then followed by feature stores. What kind of features you are want to experiment with it, and then that's where that you start training. So training for the model, which includes auto ML notebooks and experiment feature which we have at MLFlow. After the training, you finalize the model, and that model you can serve to the production environments. That is, we can call it a batch streaming interfaces or online serving endpoints or something like that. So yeah, as part of the data preparation, data source and delta tables, use Spark or native programming language libraries to connect to data sources. So there are again plenty of data sources we have. Some of the inbuilt data sources which you can use like a Spark and all. So that way it can help you. Delta tables offer transaction support, version control, and revision history for huge data sets. This has a support again, transaction support, version control, and revision history. So that way you can version the each data which you are trying to experiment the models. Feature store. So feature tables in the feature store allow you to store processed feature for model training and inferences. This part, you have a AutoML notebook and experiment. Model training can be performed using custom code or with AutoML. Here, you can also track parameters and models using an experiment with MLFlow tracking. Models, once the model is trained, you have a models ready, so which can be used. So this part, you have a model registry. Model registry can be used to share, manage some model using the model registry and so on. And the last one, if you want to deploy the trained model to the production or something like that, that we call it a model survey, that is done. So yeah, MLflow, the apart. So these are the complete MLflow end-to-end workflow. So out of which MLflow again is incorporated at Databricks, but also MLflow alone, which is an open source platform also. So that means please understand this way. If you want the hosted version of MLflow, then you can get into the Databricks, the one which I was showing you. But if you want only the MLflow, that can be installed in your laptop as well, and that is also possible. So that is open source platform. So that platform which is open source for managing the end-to-end machine learning lifecycle, which includes model tracking, model registry, model serving, and interface. So which are the open source? So let me show you. I have run this model in my laptop, and here you see this is the one. This runs on 5000 port number. So this is the open source. Here you have experiments, whatever experiments you want to do, and then once you are done with the experiments, here you have a model registry and some extra features which you have for the prompt and all. So yeah, this is the version which I have installed it, 2.213, which is the latest one in that 2.x series, I guess. But recently they have come up with the 3 version also. I think last week, few 10 days back or maybe something like that. So you need to check that also. So this is the open source, and here the one which you are trying, and this place, it's a cloud-based paid one. Okay, and here you get some runs. which is little bit of costly services. So you have to check that out. Okay, so what are the phases while doing MLOps, and how this MLFlow will help you. So let's go at a high level because we have covered this one in the last couple of sessions as well. So the first phase of MLOps is like business understanding and problem definition explanations. So you have to first understand what kind of model you are trying to build. So that kind of understanding you need to have a clear definition of it. So yeah, clearly identify the business problem, define what success means, including matrices and business goal, establish how ML can help achieve these goals. One example, it can be a business wants to predict customer churn. Success is measured by reducing the churn by 15%. So the first thing is business understanding and problem definition explanation. Second thing, which is you have after that you have a plan in place, then you have to collect the data and prepare for that. So yeah, data collections and preparation explanations, which includes like a gather relevant data from the multiple sources, clean, pre-process, transform and label data, prepare data sets for training and validations. And the example can be collecting customer data, removing duplicates and error, handling and missing values, splitting data into training and test sets. So in this phase, you have a data ready for the use for the model training. Now, the third phase which is coming is model development and experiment. So what you do here with the model development and experiment, here you build and train model using the different algorithm and the data sets which you did in the phase 2, and then experiment by adjusting hyperparameters, features and method. Track experiment and model performance. This is where the ML flow helps significantly. Remember, whatever the experiment you are doing it, ML flow will help you to experiment, and all the matrices and parameters you can see that, and you can tune actually. So yeah, this is one example here is like building various predictive models. For example, random forest. This is the very popular model got developed. XGBoost, neural networks, and comparing performance matrices. So these are the things you can do at phase 3. Phase 4, model validation and evaluations. So model validations and evaluations, uh, here you can evaluate the trained model against the chosen matrix. You can compare their models as well. Look at the accuracy, recall, precisions, and many scores. Ensure model meet performance requirement and business standard, and perform cross validation and fairness check. Example, trying your churn predictions model on validation data, ensuring accuracy and fairness, and so on. Next one is deployments. Once the model is trained and finalized, developed, you have to deploy the model for the further use and then uh, giving the work. So here you deploy the selected model into the production environment, make it available to end users and other applications through APIs, web services, and batch processing. Example, deploying a churn prediction model as a REST API endpoint that the CRM application can use to identify at-risk customer. And the sixth one, model monitoring and maintenance, where you have this is a live model, continuously monitor model performance in real world uses, detect performance drops or data thrift, changes in the input data patterns, maintain and update model regularly to ensure accuracy over time. Example, monitoring prediction daily, checking if the churn model still predict accurately or if it is becoming outdated due to the new customer behavior. This one we have to do as part of the automation and CI/CD. That means whatever the model development life cycles, you have to automate it. So yes, you have to set up a pipeline from the training to deployments, everything, and use continuous integration and continuous delivery principle for seamlessly updates and releases the model. Next one is governance and compliance, which will ensure ML model meet regularly compliance, fairness, privacy, and ethical standards. And the last and which is like a feedback loop and continuous improvement. This will continue. So yeah, as part of model development, these are the development phases which we had, which includes like data preparation, exploratory data analysis, feature engineering, model training, model validation, deployment, monitoring, and many more. So these are the things which we do in the MLOps. Now the question is where the ML flow can help you. So we had a business understanding and problem definition, data collections and preparations, model development and experimentation, model validation and evaluation, deployment, monitoring and maintenance, CI/CD compliance, and feedback loop and CI, where it will help you. So if you look at this, the first two where the ML flow will not help you, but the primary use is for the model development and experiment, but also validation and evaluation and deployment also. ML flow will help you at a Databricks minded. Okay. uh, and then not in the open source. And then monitoring, maintenance, and automations and CI/CD, this you can do at the Databricks. uh, and remaining also you have a Databricks but not at the open source. So basically if you are using Databricks ML flow, then mostly from the phase 3 to phase 9 you would get those features. Okay, so now many of the time you are looking for some better tools other than MLflow for the each phases. So here if you're looking for it something like this, again this table will talk about it, some of this stuff like how can you do, which are the tools can be used for business understanding and problem definition. So some of the tools can be used like a Jira, Confluence, Trello, Notion, which some of the method which we have is like cry, SP, DM framework, agile methodology, in terms of data collections and preparation, so many tools are there. For the collections, Kafka, Apache NiFi, Glue, Data Factory, Airbytes, and all, you can use it. For preparation and cleaning up the data, again many libraries you can use. One of these is very popular, Pandas, Dask, Apache Spark, Databricks you can use for the data engineering, data science feature, the one which I was showing you. AWS SageMaker, Data Wrangler also you can use it. For model development and experiment, what framework you can use it. So framework which we have a TensorFlow, PyTorch, Scikit-learn, XJBoost, Light, GBM, Cat Boost, Hugging Face, Transformers, and many more. Some of for the experimenting and tracking, MLflow, TensorBoard, and few more are there actually online, Neptune.ai, Comet.ml. And all. For validations, again many tools are there. Some of these you can see that scikit-learn matrices and some libraries are there. For deployments, again MLflow can be used at Databricks, AWS SageMaker, Kubernetes, Kubeflow, and Kserve also can be used. Azure has also some platform. There are so many others as well. Monitoring, again so many tools are there which can help you to monitor. CI/CD, some of the tools like GitHub Actions, Jenkins, and so on. So yeah, these are some of the tools which you can use for getting done. Okay, so now what are the next 10 most common problems solved by MLflow? So one of the problems which we face is like uh, difficult to remember and manage what changes parameter, dataset, and hyper parameters you have tried. That means something like how can we track the experiment? And solution is MLflow. So MLflow automatically logs the experiment, so you clearly see and compare the past runs. Then this performance hyperparameters and so on. Second one is like versioning, model versioning. So the challenges which we have is like a confusion about which model version perform the best, because you don't have a versioning. So you run multiple times the same model. So which version has run best? That is where the ML flow automatically give you that automatically the versioning. ML flow gives the clear versioning and organized models, showing which performed best and when. Now, third one is reproducibility of experiments. So sometimes you difficult to recreate a past experiment precisely, as small changes can affect results. Here, MLflow record detailed info about your runs, each runs, ensuring you can reproduce results later exactly. Next problem is like how can we deploy model deployment complexity. So challenge what you have is like deploying models into production or API endpoints can be complicated and error prone. The solution is MLflow, which simplify the model deployments, making it straightforward to serve production reliably. One of the problem is like a difficult for team to share ML experiment and models efficiently. And that is where the solution is MLflow offer a shared platform accessible to entire team, clearly documenting all experiment and model. Another challenge is like managing many models scattered in various places without clear organizations, where MLflow provides a centralized model registry, clearly organizing all models in stages like a testing, stages, and production. Another one is how can we monitor? So sometimes it's hard to continuously track performance and changes of the models in production, which will be helping you by the MLflow. MLflow provides easy integrations to monitor your models, making it easier to check if they degrade over times. Second one is scalability challenges. Sometimes manually tracking experiments become difficult as projects grow larger. What you can do, solution MLflow, easily scale from a small personal project to a large enterprise environment without complexity. So some of the problems which we have, uh, which is solved by MLflow, also including the organizing data set, logs, plots, reports associated with the experiment, and can be messy. So in summary, MLflow simplify, organize, and enhances your ML workflow from initial experiment to deploying your models, solving these major challenges with each. So what are the MLflow components we have? So primarily we have four components: tracking, models, projects, and model registry. Models and model serving you can consider as a one part. It can be different part also for timing. So yeah, so tracking, projects, models, and model registry considered a bit more most important component of MLflow. So this features, how can you install the MLflow open source? I think you have a command line pip install MLflow, uh, which will install the libraries, and after that you have to say MLflow UI, which will open up the UI at the 5000 port number. So that I'll show you in the demo as well. So these are the four components you see. Again, let me show you: tracking, projects, model, and model registry. So if you go to here, here you have tracking, models, model servings, and all. Here you have, and workspace. Here you have, where you can write a code and things like that. You can do that. Run is here. That means any models which you run, you can see here. In the open source, you see that experiment. You have all the models, and you can share the experiments also. Here you have all the models registered, You can create a models and so on. So this model is a model registry, actually register model, and each of these experiment you can see complete details, model matrices, and many more. Actually, this is the model artifacts. Here you have. So yeah, model tracking, MLflow tracking, MLflow projects, MLflow models, MLflow model registry. So these are the four components which you need to work with while working with MLflow. So MLflow tracking, which records query and experiments, code, data, config results. Pack project is nothing but a packaging format. It's like some code for reproducible run on any platform. So that means this, if you package in a projects, you can run that projects on any platform. It's like a packaging format. Models, the general format that's standardized deployment paths and so on. And the place where you store the model, which is called model registry, centralized and collaborative model lifecycle management. Okay, so this is something which you have. Okay, so how it works. So look at this here. In the tracking server, MLflow, you have all the parameters for each experiment, matrices, artifacts, metadata, and models, the one which I was showing you. Then you have a model registry where you have a multiple environments and different versionings as well, and then you deploy to the serving. Okay, so we now understood what exactly the components of MLflow. So once again, MLflow including tracking, projects, model, and registry. Tracking, logging parameters, logging matrix, logging artifacts, and experiments. Projects, which is nothing but a packaging format, a reproducible run, sharing codes. Models, which is packaging ML models, standard formats, and registries like a central repositories, which where you do the model lifecycle management and models. So this is the complete flow. I will just ignore this because I have already discussed this one. Okay, so now let's discuss each component in detail. So the first one is tracking. So ML flow tracking simplify how you manage, record, visualize, and reproduce your machine learning experiment, helping you to build models better and faster. So tracking also includes API and UI for logging parameters, code versions, matrices, and output files. Trackings let you log and query experiment. Supported technologies and languages include Python, REST, RAPI, and Java API. Okay, so tracking also they have a two part. One is experiment, another one is run. Okay, so experiment where you which is nothing but a primary unit of organization and access control for runs, allow you to visualize, search for, and compare runs. Two types of experiment you have it: workspace experiment and notebook experiment. Workspace experiments belonging to the workspace, not associated with the notebook, run in any notebook, can log to them. Notebook experiments associate with a specific notebook, automatically created if no active experiment for a run. Next one is run. So when you run the experiment, that is run. Single executions of model code, which is called run. The each runs contain the following information: notebook, version, start and end time, parameters and metrics, tags, and artifacts. Okay, so that is called tracking. So look at this here: parameters, metrics, artifacts, metadata is a part of all this tracking. So uh, just yeah. Okay, so When you develop a ML model, you often run multiple experiments with the different parameters, data, or algorithm. Need to remember how each experiment performed. Want an easy way to compare results later? ML flow tracking does exactly that. It automatically records important details about each experiment, including parameters, matrices, artifacts, environment information, and many more. How ML flow tracking works? So which basically logs parameter, store hyperparameter or any configuration used in experiment. For example, in a code, if you type MLFlow dot log underscore parent and the parameters num layers 4, or if you want to log a matrix, you look at the one example is been given, or if you want to log any artifacts, so like that. So this is how you log the all the informations on the parameters. ml 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 flow tracking UI dashboard, which provides an easy to use web-based user interface. Visualize all experiment in an structured way, compare parameters, matrices across run, download and preview logged artifacts easily, and so on. So now let me show you uh, one of the tracking features. So this one is MLflow, and here let me show you that code. So this code I have run, okay, and this is my model. Here we have trying some data, and what I'm saying, logging this, tracking this model performance run at this place, which is MLflow UI, and we are naming this experiment as a my improved experiment, and we are logging parameter metrics and stuff like that. This model we are setting as like a my model. So if you run this, I have run this already, so this way you can run, and here score, you got it, model scores. And now here you see the run has been completed. You can see the experiment. This is the unique ID for each experiment got added, and now your experiment is available here. And now can I show you? So refresh and go for this. See here, this is the one 25 seconds ago. This is the experiments. Earlier also I run multiple experiments. Before session I was checking if it's working well or not. So here it is. So this is the one experiment. This is the one experiment. My improved experiment, if you see, this has the use label the experiment. Else by default, if you don't set it, it will come along with the default name. So now this is my experiment name, okay, and now refresh. What happened? Just wait for it. So yeah, so this is the experiment name, okay, and here I'm trying the multiple experiment, multiple run. Each run is one experiment. So each experiment you will get one run. So experiment 1, experiment 2, 3, 4, like that. These names you get it randomly. You can set the name if you want through the code. But now I have added this experiment, and now you have a complete detail of the experiment what you did. Most important thing is parameters. Here you see your learning rate was 0.1 value, and then second important one is matrices. Hypervalue is not passed here. Now if you see that created by, this is my username, and this is the experiment ID, status, run ID. So every experiment will have a unique run ID. This is the experiment ID. How much time it took to run this experiment? 16.9 seconds. There's no data set used because it was embedded in the code itself. And tags, you can add a tags also. And what is the source for this experiment? So this code which I was running. So here it is. Now which model you try to train this code? So sklearn, which I have used, and I have not registered, and there's no prompt for it. uh, Other matrices, if you want to see here, there's only one matrices here, but here you see the broader view actually. For that, system matrices are right now none. Trace, for this you can see that for that experiment here you have, so the code, some lang chain. So this tab display all traces logged to this run. MLFlow support automatic tracing. This is the trace for many popular generative AI framework. Follow the steps below, and so on. And here these are the models which this model you can register it. So this whole code is like one model now, trained model. Okay, so here these are the Python libraries. Here you have environment for it, models, pk, this is the package actually, pki, Python package, and conda yaml, which is like a dependency management, and this is a project. Okay, so whole thing is one project section. You can register this model which you developed, but not now, we'll do that later. So this is called experiment. Are you understanding, all of you?
Yeah, yeah.
Okay, so second one is projects. So MLflow projects are component of MLflow that help you organize, share, and run your machine learning code consistently across the different environments and systems. So basically, you can say it's like a packaging, is a way to package the code in a way so you can run it in any platform, in your laptop or Databricks or somewhere else also. So like this. So which is nothing but the package ML code into reusable and a reproducible form. Each project just a directory of files or a Git repository containing your code. Simple. Allows sharing with other data scientists or transfer to the production. That's like a packaging. So the MLflow projects will have a spec, code, config, dependencies, and data. The one which I was showing you, this is the projects, this one here. Okay, here this is the whole projects. Spec is this one. Okay, so complete spec you have here. So what exactly is an MLflow project? So MLflow projects is essentially standardized way of packaging your machine learning code. Think of it is as if creating a recipe that clearly define your code, dependencies, execution environments, and parameters. So the code is nothing but the scripts or notebooks that you use to train and evaluate your models. Dependencies, again, which is the Python libraries and other requirements to run your code. Execution environments detail on how and where your code should be run. Example, locally, cloud, or containers. And the parameters input value that can be changed when running your code, like a learning rate, dataset, locations. Why use MLflow projects? So machine learning code often runs into the problem like it works on my machine but not elsewhere. You have a dependencies issues, reproducibility issues, and all. So MLflow projects solve these issues by providing a standardized format and easy execution method. So when you look at the any projects, MLflow projects, you will something like this. I was showing you in the UI earlier. The spec file, conda file, Python code, some data set if you have used, and some README documents. Typically, this flow only, this code only, this project only, we commit to the GitHub also. Okay. So what are the example for specifications? So here you have a example for specification like here, something here we see ML model. Here you have model UID, prompts, run ID, and all these things. So like this. Okay, so running MLflow project. So if you want to run MLflow project, the whole directory, how do you run it? So command line is like you can run command MLflow run and the whole project, and then any parameter you want to pass, for example, something like -p and then parameter name, value, and all, you can do that. Okay, so what is the benefit of MLflow projects? Reproducibility is like create an exact condition to run experiment, portability, and collaborations. Portability is the important one, where you can run your ML code consistently across local machine, cloud platform, and container. So what are the common uses example? So packaging your ML experiment clearly, running experiment repeatedly on different data sets, deploying experiment easily to cloud environments, creating consistent workflows app for ML pipelines. Okay, so now next one is models and servings. So what is the models? So after the experiment with some data sets, you will have a models. Models, the one which you want to deploy. Trained one. So MLflow models is a key component in a MLflow that helps you package, manage, deploy, reuse your trained machine learning models in a standardized platform independent way. So manage and deploy models built using popular machine learning libraries, support multiple model serving and interface platforms like classic MLflow model serving using REST endpoints. Serverless we have like Knative and all. Real-time interfaces allow scalable REST endpoints. So classic MLflow serving, which includes host ML model from the model registry as a REST endpoints, updated automatically based on availability of model version and stages. Models served on a unique cluster which serve all non-archive version of model, useful for low throughput and non-critical applications. Again, serverless real-time interfacing, where it include exposes ML models as scalable REST API endpoints, uses serverless compute like Knative uh, endpoint, and communicate resources managed by Databricks. You can serve the models at Databricks also, though it's a paid services, but you can do that. Okay, so real-time interfacing, which is nothing but a one-click launch of endpoint. That means the moment you click on the deploy model, you get one endpoints, and that you can start using it. High availability and scalability, built-in monitoring dashboard, and feature stored integrations. Okay, so yeah, ML flow model is a standardized format for packaging trained ML models, making it easy to save, load, and reuse models later without confusion, and also deploy also. So deploy models to different environments such as REST API, batch production, cloud platforms, and so on. So how your model will look like? So MLFlow model typically look like this. You have ML runs, the number of runs, let's say 0 is runs, then run ID inside that artifacts, then model. And this is something like a model will be there. So let me show you this one in your real time. So if you go to this directory, start dot, here. So now if you see that this was my code initially, which I was trying to experiment, but there is a model. So model is ML runs 0, and here it is. So this is the each run has created one model, and which is the most recent one. Let me, I think this one, right? So like this, here it is. So here you have artifacts, matrices, parameters, tags, and so on. Code is not there. So this is the not full one actually. Here it is. This is not there. Yeah. Artifacts is nothing. Input is there. Matrices is there. Yeah. Parameters are there. Yeah. This is the one. This is the train model. Okay. So something like this, you will see that. Artifacts, model. So like that. So this directory will, you'll see something like this. Okay. So
But in that artifacts model is not there, right? The one you have showed it live, it's not there, right? It's created outside.
yeah. So here I was not able to locate a right one. So I can check that. Okay, my bad. So it has not generated. Why? Because I did not register a model so far. Okay,
Oh,
so my bad. So I was supposed to show you the demo. So like this. So now there's one model which I registered, and now you see that here under this model. So now you have other things. That's the reason that artifact data was missing actually. Anyways, I'll come back to that one. Okay, so which directory got modified? Not this one. Timestamp is not updated properly. So now if you see that, I think this was his last, right?
yes.
No. Okay, I'll clean it up and then it will make some sense actually.
I think it's not properly getting updated, I think. Not properly getting synced.
Yeah, the timing is not matching actually. Not sure why. Okay, I'll check this. Let's wait for it. Okay, so you will see something like this, run ID and so on. Now this is a model. Okay, one second. Yes. So I registered 3 times. Let me search for Rajesh now. Here it is. But where is this directory? And okay, this is the version 1. This is the location for artifact. So let's follow this. So it should be 7.8. Uh-huh. 7.8. And what was that? Artifacts 6666 artifacts. My model. Here it is. So you can trace from this YAML file. That way it will be easy for you. I think timestamp is not getting updated properly. Okay, so that's a model. Okay, how can we deploy a model? So if you want to deploy a certain model, let's say my model name was Rajesh. In this example, you have a RF underscore model. So serving can be done. So the command is MLFlow models serve -m and model name and then port number -p port number, and then based on that your model's endpoints specifications it will be there. So this is the way serving, this is the serving can be done. So model, you can save and load model like this. This is the code for creating models. So what I did right now, just to show you the demo, I got into the experiment and manually registered the model. But here you have a code to save the model. Then if you look at this, save model and so on. So this is the way you can do that through the code also. Everything can be done through the code. And then if you want to serve the model, that means if you want to run the model at certain endpoints, some port number, you can do this. Okay, so what is the benefit for this model? So easy packaging, reusability, portability, and collaboration. So these are some of the things we have. Now registry. So registry is something like I was showing you here. This is a, you can say registry. This is the model. but this is a registry where models are available. But right now that's a local. Okay, so here this is the platform at a Databricks. This is the paid service actually. So if you see that I have so many models registered, so you can register the models accordingly also here also. So what is this? So MLFlow model registry is a centralized place to store, organize, and version and manage your machine learning models within MLFlow. It simplifies how you keep track of different models, their life cycle stages, and how you deploy them, which is nothing but a centralized model stored where models can be registered and manage life cycle stage, transition from staging to production, allow versioning and annotations of models. So this is just a screenshot I just did in front of you to register a model. That's the same thing, you can do that. Okay, so what exactly the MLflow model registry? Think of MLflow model registries like a model management hub, which clearly helps you to keep a track of all models created during experiment, version your models, define and manage the life cycle stages and collaborations. When you registered a model, these are the things you need: name, version, stages, and annotations. Through the code, how do you register a model? So this is the some code, example code is been given to register a model, and then run ID, model name, and their name of the classifier models actually. Okay, so this is something which you have. This is the whole code actually, so you can refer this. Okay, so now what I'm going to show you, uh, something like a demo for open source, and then we'll see how it goes. So first thing, you have to install the Python, and which you can do that. Second thing, you have to create a one Python environment. So anytime you work, you have to create a Python environment, and that way it is good for the all the environment you set for the Python for the virtual environments. This is optional, you can upgrade if you want it. Now you, in order to install ML, in order to run the open source MLflow, you have to install the MLflow, pip install MLflow, just like your other library you installed. This you also you can install in your Windows machine or Linux, whatever it is. Check the version. So mine is latest only. I installed today only, just a few hours before this session. So it's a 2.21 actually. Now after that you have to launch the UI. So if you run this MLflow UI, which you can see I run here somewhere here. Okay, I just half an hour before the session I run to make sure that no surprises are there. So I run it, and here you see these are the flow. So you can run it, and then you can access on the 5000 port number. Uh, Typically what happens when you run it, you will lose the console. So if you want to avoid this, you can run this command also. In this case, it will not, you will not lose the console. After that, you can access this MLflow open source version at this place. Okay, so that is a one way. Second way, let's say you don't want to use it open source, which has a limited feature, then you can come to the Databricks. It's a paid services, and you can buy the compute here and then start using it. So all the features which you have downside, here you have experiment, features, models. These are the models. Serving means automatically you can deploy a model, and each model can be accessible across the, endpoints you get it, and anywhere people can access it. Okay, so how do we get started? So first you have a code. So some sample code I have already given in this tutorial
On
only.
Databricks also you'll be showing a demo, huh? MLFlow
Yeah,
diagram.
yeah, Databricks also I'll show you. So this code, you have a sample code which you can run. Now it's a very simple code. Here you are using some of the random forest regressor, and you want to track where you want to track. So this URL can be Databricks, but right now it's local. So because my MLflow server is local, right? Some data I'm loading, some auto log enabling, some data sets for the regression test training, and so on. So this code I put it up here, and here I'm going to run this code. So how do you run? I think I showed you already. So this is the directory. See here, this is the file. Okay, so run this python da da da, and this code can be large also, depends on your use cases. This is the hello world program kind of it, simple. So here I'm training the model, this model, and registering as a my model. You can change the name also, but that's sufficient for this. So it'll take a couple of seconds. Now I experiment my model and results are out. Now I go to my MLflow, and this is the model which I experimented, you see here. So now complete details you have about this, how many experiments I did, whatever the data sets used, and what was the durations, sources, and so on. So complete details you have here. This is the data sets I use. So basically two models we had it so earlier. So now I use this one. So you can check this complete details, track that how many runs you did. Last run I did this one. Look at the performance, uh, and look at the your values which you are tracking, matrices. This one. Okay. So here these are the matrices you have. These are the parameters hypertunings you have. So see that which is having the better performance, and complete details which I showed you, matrices, system info. So now you can compare each models, each experiment, and see which went well with what data sets. Learnings was efficient. Now I decided, okay, this model is good and it is matching with some of the values which I was expecting. Okay, developers will decide, and the matrices are also as per the expectations. So what I will do, you can register this. So here, register this final DevOps code model, and this was the final. So I track and trained, reviewed, model is finalized, and now registered. Okay, so and this model version, you see, automatically version 1 is given. Now if you give the second time the same name, register model, automatically versions will be there, version 1, version 2, version 3. So like that. So let me do one more time. This time, same model, you want to register. Okay, promote one, DevOps school. Oh, this one I was expecting the next version, but because I did not train it, it did not come it. So I'll have to train it one more time to get the version. Okay, so here you can declare the versions, all these models you have, and if you want to deploy it, okay, you can deploy. So right now the serving is not in the local that you have in the data bricks. So I'll show you that. So like this, you do that stuff. So here in this tutorial, same thing which I try to help you with. Now, how can you do with Databricks? So go to the experiments, and here you can, take some data and choose some model to experiment. So for example, uh, you take some data like here and name it DevOps school. The artifacts locations, let it be default, created. This experiment name using UI, I did this. Now, here you have to take some data. So now you can take new run using notebook. That is done. And just a second. Experiment. Just a second. So in that I created DevOps school. I was not having the sample data. It's a new account. So let me create another experiment using GenAI where we are getting the simple data. So let's call DevOps. And here I'm getting some sample data from the develop locally or Databricks notebook. So here I'll go for some sample data and do have this is the workspace. I just need a sample data, not so much. Just a second, hold on. Okay, so I'm getting the sample data from here. So let's try this one. Forecasting all samples data here, and let's go for health variety sample data, and I'm using this as for the training. It has a 2 column. Okay, so some other data is selected. Now which column you want? So randomly I'm going for any sample data. Now forecast horizon, this is 7 days. I just want 1 day because others will take too much of time, 1 hour or something. And prediction, that it will be, let it be default. And prediction data path, if you want to select somewhere, you can do that. So and model registration. You want to register a model. Here you can select, and you want to, let's say you want to register at sample. Confirm. This is sample will be registered. Model name DevOps School, and so on. So here what I did, basically I selected trend forecasting model, some sample data, and forecast horizon 1, and I wanted to register it also. Some locations I put it, name and all, some advanced option, start training. Now I clicked on it. Did I miss anything? Experiment name test 1. What is this? It's not responding.
I think for
Okay.
Databricks, we need to create a cluster first and then only you'll be able to configure it.
No,
I used to go.
I have a free credit. I just
Oh,
5 minutes back I did actually.
okay.
See here, this one. So just a second, let me try one more time. Okay, I think no error is coming. Okay, just a second. Let me run the existing one and see if it is able to run. And if not, then there's a problem. I don't think so there should be any problem. Okay, it's running now. I think it's only one allowed actually. Let me check. Maybe second is not allowed or something. So I have to delete this one and then see that. So yeah, this is the something which you can do. Create as many experiment here, run it. So at Databricks here it will run, and you will get the status each runs. And now once pre-processing, tuning and training is done, then you can register this as a model. The moment you register, you will see all the models here, and this model you can deploy. Let's say this is the model which I used, let's consider, and you can serve this model. So this is the llama free version of model. You can serve this model, and automatically you will get one endpoints. Name this the endpoint will be created. So let's create a one endpoints. Let's say DevOps school test, something like that. Okay, and some of the things which you can select here, what exactly all you want, and create. Now all the serving models, this is the URL. Okay, you can access it globally. Right now it's in pending, but all the serving models you can see here serving endpoints. So something like here you experiment the models, try the run, all the runs will be here. After that you register the models under the model section, then you can deploy the models and it becomes serving here. And then anyone in the whole world who wants to access this model, this URL you can share with them.
And we
And
integrate this with the MLFlow, the one you have shown where you are maintaining the models, right? So here, if I develop, can I push it onto the MLFlow hub?
oh yes, you can do that. You can do that. So here, basically, in the code, this code you have to write after the model is trained. You registered at the models and serve models here, and probably after this serving here. So that code using that you can do that. So for example, let me show you.
You're telling that the dot log underscore model, there you're asking me to modify and give the
Yeah,
MLFlow hub.
yeah, yeah. So let me show you. Modify this code to add Databricks API. Just a second. Databricks cloud to track or experiment and register a model there only and only. After that you can make it for serving also. So API of Databricks, you have to add it.
Okay.
So
Raj, how about if I create a notebook, I want to add into an intermediate step, I can also add it as an intermediate step, right? The notebook.
say, yeah. So first thing, yeah. So URI will be Databricks. This is your username, okay, for this, and model name will be here. Accordingly you can set this. So yeah, that's possible. So it will be directly go to the Databricks. What you said, next one?
Suppose, let's say you're using one experiment, already existing one and running, right? In
Uh-huh.
between, if I create a notebook and in between I will be adding the step as embedding. So that way also we can add it, right? How can we create that boxes like pre-processing? How can we create that boxes? I mean, how can we convert that code into separate nodes and connect them on Databricks?
Okay, so here basically you are saying the CI/CD flow.
You showed me, right? First step is pre-processing, then we are converting into model,
Okay,
then
okay,
putting
okay.
it to pickle.
That is a data pre-processing. So at Databricks you can do here uh, workspace here. This is the typically done by. These are the space we have, and second one
This
you have.
part is
Uh,
fine. So you showed me one flow, right? Can you go back? You showed me one flow, right? No, not this one. On Databricks platform only. You told have previously run and you have showed the pre-processing box. Then where is that modal? Go to once modals. In experiments, I think you clicked on your thing and you have showed that running. You have showed pre-processing. Then going to next step. Yeah, for build a forecasting model. Just click on it. No, not this one. You have given a diagram. You have showed me a diagram on Databricks in your initial explanation.
Okay, so here what we're trying to do, um, this whole
No, no. What I'm
whole
telling is, you showed me the code, right? First, what you did, you have taken a sample experiment and you ran it, right? Then it
Mhm.
showed your pictorial representation also. Like in Airflow, it will show the nodes connection, right? One execution done, two. In that way,
Yeah,
on Databricks also, it was showing.
this one, this one.
After pre-processing, I want to add an embedding box. After that,
Ah,
tuning. How to add that one?
okay, so this is a run. Okay, so this
Um,
run, it's come from your experiment here, and forecasting has a some built-in built-in model. So this you cannot modify. But if you want to create your own, come to pipelines here and create your
oh,
custom one. And here you can link whichever you wanted actually. So job, ETL pipeline, ingestion pipeline. Ingestion means get the data. See here, first thing,
mm,
get the data, process the data, and then run this notebooks here,
yes, yes.
MLOps. So this you can create it yourself, and then this
Understood.
uh, the job runs will become here. So you can create a
Oh,
pipeline here. That was I use the inbuilt feature actually.
okay.
Okay, so now if you see that I have some issues in this account, but anyways, so uh, so this got failed again. But here, same way you get a model here and survey. So now if you see that I just deploy one model, one of the Llama model, and this is the URL. So anyone whom you want to offer this model, you can share this URL. And right now unauthorized. So basically this model, how to use it, that tutorial will be given as per the code and all kind of things. So most of the time REST API and all kind of things will be there. So this is how you serving the model and get running. Now anyone who uses the model, here you will see the latency, request rate, and complete details. So this is called monitoring phase. Okay.
Okay. In case if I have to push this model onto MLFlow Hub, then the code you asked in ChatGPT, right? Like that, I need to modify the code and then push it on MLFlow Hub, right?
Right, yes, that's there.
Uh,
So in the code itself, you can write everything where whatever you want to do. You want to track somewhere, you want to register a model, so this code will register a model. This one. Okay. You want to publish, so lots of things can do that. Okay, so just practice it. First local one only, that is the easier one, and see that how it goes. If you have any questions, you can ask me in the chat box. I'll respond it to you. Okay.
okay. Raj, we have few more concepts, right? Like Q flow demo. It will be taken next week.
uh Qflow. Okay, I'll just check, and then I'll tell you that next week when.
Yeah,
Okay.
even some of the concepts